If you're making a game that has a user interface with some kind of menus, this is the video that's going to show you how you can structure your UI so it doesn't get out of control. Hey, Chris here from LlamAcademy, here to help you. Yes, you. Make your game dev dreams become a reality. Listen, today we got a new environment going on. It's going to be awesome. We just moved into a new house. Hopefully the audio sounds better. Hopefully the video, it'll get better. You can see a bunch of stuff in the background. It's not important for this video though. What is important is we're going to talk about how to manage your UI where you don't have a bunch of just all kinds of weird tangled up references in your code that makes it unmanageable as you scale up your UI. To accomplish that, what we're going to talk about first is how do I structure the UI in my games. I generally have everything under a single canvas, but you can make this work with multiple canvases as well. If you have a really complex UI where you need a bunch of different layers going on, you can do the exact same thing as we're going to do here, just with multiple canvases. Underneath that one canvas that I'm going to use, I have a bunch of full screen that scale with the screen size pages. We're going to call them pages. They can be pop-ups, they can be full screen pages. Doesn't really matter. We're going to call them a page just to make it really simple. And under each of those is where we define the different content for each page. Such as maybe for the main menu, you have some buttons that are some options, and each of those takes you to a different page to do something. Like a settings button would take you to a settings page where you can have all kinds of different controls, and each of those controls needs to do something. Architecting it this way where the page manages how the page moves in and out, having a menu controller that manages all of these pages, where between the menu controller and the page, those two are responsible for sliding in, out, fading, whatever animations the pages are going to use to come in and out. Playing the audio, and the menu controller determines which pages are visible at a particular moment. Doing that allows you to move all the logic that you would normally put into the game object that has the page and is managing the transitions, moves it out of that into something that is strictly, let's take the settings page, controlling the settings, sliders, toggles, whatever's going on there, and not anything to do with the page itself. That makes it significantly easier to tell what's going on and what you're trying to do on a particular Monobehaviour. The last thing to talk about right here is the menu controller manages all these pages using a stack. This is an abstract data type that's extremely common and very high performance, and you can visualize it like this. Imagine you're going to build a tower. You put one block, we're going to call that pushing a block onto the stack, and then you want to build a new floor, so you push another block onto that stack. And you just keep pushing stuff and the stack gets taller. If you get to the point where you want to remove something from that tower, you pop a block off from the stack. That's the exact same thing that we're going to do here when we're talking about pages. We're going to push a bunch of pages so they can be layered on top of each other. So if you have a pop-up that you still want to see what's going on behind it, you just push a new page on top of it where it has a transparent background. Hey, and just really quick, I want to give a shout out to my Patreon supporters. I really appreciate it. Every bit helps the channel grow, reach more people, and add value to more people. And that means more people are making their game development dreams become a reality. If you want to help me in that cause, you can show your support on Patreon, patreon.com/LlamAcademy. You can get your name up on the screen. You can get a voice shout out starting at the silver tier and some other cool perks. Special shout outs to Raphael and Andrew Bowen for being the silver tier supporters. I am so grateful. Thank you. In this scene, we have a pretty standard menu. We've got a background image, we've got some title text, and a few pages that we'd like to be able to move between. The problem is, of course, we haven't hooked up these buttons to do anything, so we can't go from the main page to anywhere else. To help us manage all of this menu, let's create two new scripts, a page and a menu controller. If we open up the page script in Visual Studio, the first thing we're going to do is add a require component type of audio source and type of canvas group. We'll also add a disallow multiple component attribute because we only want this game object to have one page to control it. We'll create three private variables: private audio source, private rec transform because this is a UI component, and a private canvas group that you know we're going to get all of these on awake with get component. We'll then add a private serialized float animation speed, set that to 1f by default, a public bool exit on new page push and set that to be false by default, a serialized private audio clip called entry clip, and a serialized private audio clip called exit clip. These will be the sounds to play whenever the page comes in or leaves. We'll also add a private serialized entry mode, and entry mode is not something that comes by default. This is a script I've already made, an enumeration I've already made that I use in my own projects. It can do nothing if you just always want it to be there. You can have it slide, you can have it zoom, and you can have it fade. These are the most common transitions that I know about, at least. You can add more here, of course. Going back to the page, we'll define that as entry mode and set that to be entry mode.slide by default. We'll add a private serialized direction, entry direction, and set that to be direction.left. Direction is another enumeration that I've made that's just up, right, down, left, and none. We'll do the exact same thing for the exit mode and exit direction, and define 2 private coroutines, an animation coroutine and an audio coroutine. I'll get into why we need 2 of these separately in just a little bit. On awake, we're going to go ahead and get references to the rect transform, canvas group, and audio source using get component. And we're going to set the audio source play on awake to be false, audio source loop to be false, and audio spatial blend to be 0. This is mostly just to ensure that the audio source is going to behave the way we expect it to work. So we don't want it to automatically play the clip that's assigned to it. Generally, we should not have a clip assigned, but just in case, we don't want it to loop because we're going to play stuff only once whenever the page enters or leaves, and the spatial blend being 0 means that it's a 2D spatial blend. The other thing that we're going to do here is disable the audio source. So if you want to go ahead and do that, you can do that here as well. I'm going to come back later and do that. Next up, we'll define a public void enter that accepts a bool play audio. And in here, we'll do a switch based on the entry mode. In the case that it's slide, we're going to slide in, passing in the play audio. If it's zoom, we're going to zoom in, passing in the play audio. And if it's fade, we're going to fade in, passing in the play audio. And before we define any of those, we're going to go ahead and duplicate this, make a public void exit that does the exact same thing, but just they'll call slide out, zoom out, and fade out based on the exit mode. Let's start defining these functions because we've got 6 that are undefined so far. Let's define a private void slide in that accepts a bool play audio. In here, we'll check if the animation coroutine is not null. If it's not, we'll stop it. And then we'll assign the animation coroutine to be start coroutine. And I'm going to use this class AnimationHelper that we're going to look at in just a second, I promise. And we're going to do .slide_in that we're going to pass in the rect transform, the entry direction, the animation speed, and null. Let's take a look at what's happening in there. I made this class to make it a little bit easier to manage running these coroutines. Otherwise, that page gets really out of control with all of these different animations going on. So on the slide in, you can see that it accepts a rect transform, a direction, a speed, and a unit event on end. We're going to come back towards the end of the video to talk about what that is. You can see in here, based on the direction, we're going to assign a start position, and then we're going to iterate from time 0 to 1. And we will set the transform anchored position to do vector 2 lerp from the start position to vector 2 0. That's perfectly centered in the screen based on the time. And at the very end, we will conditionally call that on end unity event. All of these animation helper functions behave basically the same way based on the direction that's passed in. We're going to assign either the start or the end position, and then we're going to lerp towards that position, that scale, or that canvas group alpha, depending if we're doing slide, zoom, or fade. If we hop back over to the page, we're going to add play entry clip right after we started that coroutine, passing in the play audio. And we'll define that one right now with private void play entry clip that accepts a bool play audio. We'll check if play audio and the entry clip is not null and the audio source is not null. Then we'll check also if the audio coroutine is not null. We'll stop that coroutine, and then we will do audio coroutine equals start coroutine play clip that accepts the entry clip. Let's go ahead and define that play clip with private IEnumerator play clip that accepts an audio clip. We'll set the audio source enabled to be true. We will define a wait for seconds wait to be a new wait for seconds based on the clip length. We will tell the audio source to play that clip with audio source.play one shot, which just makes it play a clip one time. We'll yield return that wait we just created. And at the end, after the clip is finished playing, we will disable this audio source. We're disabling the audio source whenever it's not playing because there's some CPU overhead associated with having the audio source active. Regardless if it's playing or not, there's still some CPU cycles being spent on it. And on your UI, you could have a large number of pages, pop-ups, and if all of those have audio sources enabled, you start incurring a not insignificant amount of CPU overhead doing absolutely nothing. Now I'm going to scroll back up to the awake and disable that audio source like I said I was going to do earlier. Coming back to the bottom, we will duplicate the play entry clip, rename it to be play exit clip. We'll check if the exit clip is not null, and we will play that exit clip. Then I'm going to collapse those because we're not going to do anything else in those functions. I'll scroll up a little bit to where we define slide in, and we're going to go and define all of those functions that we have not yet defined. Let's duplicate slide in and call it private void slide out. out. The only difference here is we'll pass in the exit direction instead of the entry direction. And of course, we will use the animation helper slide out, which behaves the exact same as slide in, except it's setting the end position instead of the start position. Let's duplicate both slide in and slide out. Rename slide in to be zoom in. Change the coroutine we're going to start to be zoom in and zoom out, respectively. And if we open up the zoom in function in the animation helper, we can see that it accepts only a transform, a speed, and an on end function, and will adjust the scale from 0 to 1. So we will just remove the entry and exit direction from these two calls, and the zoom in and zoom out are set up correctly. Now remember, there's one more case we want to handle: fade in and fade out. So we'll duplicate the zoom in, zoom out again, rename those two new ones to be fade in, fade out, change the coroutine we're going to start to be fade in and fade out, respectively. And on this one, we can see that it accepts a canvas group instead of a rect transform. So let's go ahead and pass that in instead of the rect transform as the first argument. And with all this copy pasting, I've messed it up two things. One, on the slide out, zoom out, and fade out, we need to call the play exit clip function instead of the play entry clip. And on the exit function, we need to check the switch of the exit mode instead of the entry mode. That's all for now on the page. Let's open up the menu controller. In here, we'll add a require component type of canvas attribute, and again, the disallow multiple component attribute, because we only want one menu controller. Then we'll add a serialized private page initial page and a serialized private game object first focus item. We'll also add a private canvas root canvas and a private stack of type page called page stack, and set that to be a new stack of pages by default. If you just jumped to this part in the video and don't know what a stack is or how it works, I recommend you watch the intro where I talk about that. On awake, we'll assign the root canvas to equal get component canvas, and on start, we'll check if the first focus item is not null. If it's not, we'll do event system.current.set selected game object, passing in the first focus item. This allows us to choose which game object should be selected by default and sets that selected state. So if you're using a button, it'll have that color shift or sprite swap. We'll check if the initial page is not null. If it's not, we will push that page. So we'll define now push page with public void push page that accepts a page. In here, we're going to call page.enter, saying it should play audio. We'll check if the page stack.count is greater than 0. If it is, we'll do page current page equals page stack.peak, which allows us to see what is the next page on the stack without popping it. And if that current page has the exit on new page push is true, we will then tell the current page to exit and we will not play the audio. And at the very end of this, we'll do page stack.push, the page that was just requested to be pushed. Next up, we'll define public void pop page, the inverse of push. We'll check if the page stack.count is greater than 1. If it is, we'll do page equals page stack.pop. We'll tell that page to exit, passing in true, it should play audio. And then we'll do page new current page equals page stack.peak again, checking that next item in the stack. And if the new current page has exit on new page push, we will make that page enter again. And this time do not play the audio because we're playing the pop audio instead of the push audio. And in the case where the page stack is 1 or 0, we will log a warning that says we're trying to pop a page, but there's only one page remain in the stack. And that, I guess, technically isn't true because you could have 0 pages, but that's probably fine. We're going to find a couple of helper functions that I'm not going to actually use in this video, but I did need to implement in my games whenever I was using the same concept. One of those is public void pop all pages that iterates over all the pages and pops them. Another one will define public bool is page in stack that accepts a page and returns if that page stack contains a given page. And one more, public bool is page on top of stack that accepts a page and will return if the page stack.count is greater than 0 and if the page is equal to page stack.peak. The last thing we're going to do in here is implement a way for us to press escape to pop a page. In just a second, we're going to update the new input system key bindings that we have to support pressing escape to call cancel. We'll define this private void on cancel. We'll check if the root canvas is enabled, if the game object is active in the hierarchy, and the page stack.count does not equal 0, then we will pop that page. If we open up the Unity editor again, we'll select the canvas and attach the menu controller there. And one thing that I find generally works well for me is setting the canvas scaler to have scale with screen size as the UI scale mode, set the reference resolution to, whatever resolution you're targeting, and have the screen match mode to be shrink. The reason I do it this way is first, it just makes the most sense with the scaling in my brain. But what this allows us to do is pre-position our pages off screen where we know they will never be accidentally in because somebody just has a wildly larger monitor than you have to test on. I'll select the main page, and in here we'll assign the entry clip to be this super high quality audio that I've made for enter. So the exit clip to be the super high quality audio I have for exit. Have the entry mode be slide. We'll make it slide up on enter and slide down on exit. To make things easier, I'm going to copy that component, select the settings page and paste that component as new. And we'll just change the direction so it will slide in left and slide out left. We'll select the loading overlay, again, paste the component as new, and we'll change the entry mode to be fade. Set the entry direction to be none because fade does not support a direction. The exit mode also to be fade, and again the exit direction to be none. Because this loading overlay is not going to move, I've positioned it directly on top of the main page and made sure that was lower in the hierarchy because that's how the canvas works, is the ones that are lower are on top, the ones that are higher are on bottom. And I've set the alpha to be 0, interactable to be false, blocks rake has to be false because it's not active right now. I'll select this last page, it's called exit page. Paste again the page component as new. I'm going to set this one to be zoom. So again, I need to position it on top of these other pages, and I'll set the scale to be 0, 0, 0. So that way we can't see it because the zoom is going to make it go from 0 to 1. I'm going to select all these pages and update the animation speed to be 4. So that'll take 1/4 of a second for it to animate in and out. It seems a little bit more reasonable because 1 second's a really slow transition. We'll select the canvas again where we have the menu controller, drag the main page to be the initial page, and set the first focus item to be the play button. Now we've done all the pre-setup, but we do need to make these buttons do something still, right? Right now, if we click them, they do nothing. So we'll select the play button, add an on-click listener, drag the canvas to be the object reference there, and select from the function dropdown, menu controller, push page. We can then see that it wants to accept which page should be pushed. So we'll drag the loading overlay to that object reference there. So we'll call push page and pass it the loading overlay. Perfect. We'll repeat the same process for the settings where we drag the settings page as the page that should be pushed there, and for the exit page that should be pushed. And the very last thing we need to do, because we want the ability to pop pages with escape, is we need to add the player input to the canvas, because that's where the menu controller is that accepts the event on cancel, remember? Set up the event system and the main camera, and we're going to change the behavior, and the default asset that gets created is at packages, input system, plugins, player input. Here we have default input actions. I'm going to drag that to that reference for actions. I'll set the default scheme to be keyboard and mouse, but we still need to set up that cancel action. So if we double click on this action, it brings us this panel that's default input actions. We'll select UI for the action map, press this little plus button on the actions, which creates a new action for us. We'll call it cancel. It's really important it's named that because we named the function on our menu controller on cancel. Set up the key binding to be escape, assign it to the keyboard and mouse control scheme. And we can see on the inspector that now there's a broadcast message on cancel that will be broadcast whenever we press escape, which will be then caught by our menu controller. If we then click play, we can click on settings. We see the settings comes in. If I press escape, it goes out. Same thing again. Clicking settings brings it back in from the right, sliding in left, and sliding back out left. If I click play, we'll see the loading overlay comes up, goes back when I press escape, and I press escape. The exit page zooms in, and we see these numbers falling down. This numbers falling down is really the thing I wanted to use as a use case for those Unity events that we saw on the animation helper. If we just click play and bring up the exit page, we'll see that this random content filler is already running, making these numbers fall even when that page is not active. That means that we have a bunch of CPU cycles running to do something even though that page isn't active. So let's see how we can address that with those Unity events. The first thing is I'll open up Visual Studio, and in the random content filler, I will remove this start function where we start filling those numbers. So now there's no way for them to start unless we use these two functions about start filling and stop filling content. What this does isn't particularly important. The key thing is that we would like something to start happening whenever a page becomes active, and we like it to stop happening after the page is no longer active. If we open up the page again, we're going to add 4 new private serialized fields that are all Unity events. We're going to call one pre-push action, one post-push action, one pre-pop action, and one post-pop action. This gives us the ultimate level, I'm going to call it the ultimate level control about when events will take place in the lifecycle of our pages being pushed and popped. If we'd like something to happen before that page becomes visible, we will use the pre-push action. If we want it to start happening only after the page is already visible, we will use the post-push action. And the inverse is true whenever we're going to pop a page. Before we do anything about popping the page, we call the pre-pop action. And after the animation has completed, we call the post-pop action. Let's go ahead and hook these up. On enter, we will do pre-push action ?.invoke, which is basically just checking if the pre-push action is not null, then it will call it. We'll do the exact same thing on exit, is pre-pop action ?.invoke. On all the coroutines we're going to start, wherever we passed null before, we're going to pass in a post-push or post-pop action, depending on if we're coming in or going out. So on slide in, we're going to add in the post-push action. On slide out, we'll add the post-pop action. And we'll do that for each one of these coroutines that we're starting. If we hop back to the Unity editor, we'll select the exit page, and on the pre-push action, we'll add one new event to happen here. We'll drag the random content filler to that object property field, and for the function to call, we will select random content filter, start filling content. And finally, on post pop, what we're going to do is do the exact same thing, add a new event, drag the random content filler to the object reference, select from the function, random content filler, stop filling content. We're waiting on post pop because we don't want the user to see that all of those numbers are destroyed before that page is off screen. We're waiting until after the animation has completed, and then we're destroying all of those game objects. So if we click play, if we make the exit page full screen, we'll see it's just black. If we then reset the scale and click on exit, we'll see the numbers start falling. We'll see that they stay until after the page is already gone, and then they're all destroyed. One other option we should take a look at is the exit on new page push. So far that's always been false, so our new pages stack on top of the previous page. If we enable this, the previous page will appear to be popped when a new page is pushed, but whenever we pop that page, the previous page will come back in. This makes things like the slide animation whenever we have not full page content look a little bit nicer. I hope that helps you understand a way to really organize the way that you manage your user interface, implement different animations, play sounds, have custom actions that run before you pop a page, and have custom events that come up whenever you want to push a page, after the page is pushed, before you pop a page, and after that page is popped. It took me a while to come to this point where I really decided, I need to come up with a structured way to manage my UI. I was doing all kinds of weird, crazy stuff. I probably had 3 or 4 different iterations of just trying to mess around with stuff, trying to make it work in my first game. And finally I settled on this, and I've been using it ever since then. That was back in 2016. So about 5 years now I've been using this pattern for my UI, and I found it very useful, very easy to implement, and also really scalable as my UIs get more complex and I have more settings, more pop-ups, more notifications, all that kind of stuff can all be managed in this framework. If you got value out of this video, please consider liking and subscribing to help the channel grow, reach more people, and add value to more people. There's new videos posted every Tuesday, and I'll see you next week.